Hi everyone, this is the first lecture of the first week, and today we're going to talk about the difference between population and sample. Most of the material covered in the first week comes from Stock and Watson chapters 2 and 3. We're going to start off with an empirical problem related to class size and educational outcome. The policy question here is, what is the effect of reducing class size by 1 student per teacher on test scores? In order to answer this question, we need a data set. Here we have 420 K-8 California school districts. The variables that we're interested in are, first, the district average 5th grade test scores, which are Stanford 9 achievement test scores combining math and reading scores, and also the student-teacher ratio. Here we're going to abbreviate them into STR, and this is the number of students in the district divided by the number of full-time equivalent teachers. Let's look at the data set. Here we can see that the average student-teacher ratio is 19.6 and the average test score is 654.2. We can also see the distribution of student-teacher ratio and test scores. For example, about 10% of the school districts have less than 17.3 student-teacher ratio. Even though this table gives you how the student-teacher ratio is distributed and how the test score is distributed, it doesn't tell anything about the relationship between test scores and the student-teacher ratio. Before we delve further into answering our policy question, let's look at the difference between population versus sample. Population is a collection of all data points of a variable, whereas the sample is a subset, part or portion of the population. We make this distinction because it can be very expensive and sometimes impossible to collect population data. Let's say we're interested in the average height of university students. In order to calculate this, we would need to ask every single student what their height is, and then calculate an average of that. But this would take a really long time and it can be really expensive. So generally what we do is that we take a sample, say about 100 students, and ask them what their height is and take an average of these 100 students. In our policy case, the population of interest is all school districts in California, and the sample is 420 school districts. The sample can actually look like this. The school district 1 has an average test score of 645 and 25 students to each teacher. School district 2 has an average test score of 650 and student-teacher ratio of 15, and so on. Let me emphasize here the importance of random sampling. In statistical terms, we call this having an independent and identically distributed sample, or IID sample. It's important to have a random sampling in order to have an estimate that is not biased. For example, in our case, if we were to sample school districts from only high-income areas, this can bias our estimates. For instance, if we are getting test scores from only high-income school districts, which tend to have high test scores, then our test score average will be biased upward, and we don't want to do that. So it's important to have a random sampling. Let's talk about the definition of population parameter versus sample statistics. The summarizing numerical measures are called parameters in the case of population and statistics in the case of a sample. Usually we don't have any information on population, so the parameters are unknown. Let's say we're interested in the average salary of all adult males who are working. In this case, the parameter is the average salary of working adult male in the US. But we don't know that because then we have to sample, or we have to ask every single adult male how much they make and then average them. Since we don't have information on the whole population, we usually take a sample. And this sample is randomly picked from the population. We can have 100 people that are from Ohio or 100 people from Maryland. And depending on the sample, we can have different average salary. So the sample mean or sample average, which is called statistics, are random, and it's a random variable. In short, we pick a sample from the population and calculate the statistics, in this case, sample mean, and use it to estimate the unknown parameter, in this case, population average. If you want to learn about the population, there are two different ways of doing this. First is called descriptive statistics, which are measures such as mean, mode, median, skewness, covariance. And we can summarize the data from population if our population is known. Or if we don't know the population, then we can take a sample and summarize the data using these descriptive statistics. Another method is called inferential statistics. In the case that we don't know anything about the population, then we take a sample from the population and conduct methods such as hypothesis testing or estimation to infer about the population that we don't know.